everyone. Today I'm going to present about my project results and analysis about my project. So just a second, please bear with me and share the screen. So my project is yeah, yeah. So my project 4 is about uh, it's about the results and analysis of my web application, which is AI threat AI threat monitoring and risk assessment system. So what my web application does is uh, as you know, there's a lot of uh, data poisoning, or we have lots of models wherein we have to train in data for AI so that it produces accurate results. But most of the time, what happens is some of the data are getting poisoned intentionally or not intentionally, because let's say if a part of a data is it's not correct, so the whole model might get collapsed, or the analysis or the result might not come out perfectly because of the data which is inputted, so that might cause a problem. So what my web application does is that it takes in the data, which is a robust data on which the AI is trained, on which the model is trained, and it gets all these values, and then we train it. And after the model is trained, then we can see, if we input data, we can see that if the inputted data is actually closer to what the data is supposed to be. So that's the software. It's just like looking at the system where if, let's say you're predicting a value of a car, and if you inputted 1 million or 2 million for a car, for a BMW car, accidentally you get that value. So this this particular web application finds those errors, that the car is not supposed to be in so high price range. There's something wrong with the data, so you can look into it. So that is my basic idea of my project. So let's go through my results and how my project is running. So it's the same thing which I've said earlier. It's about the results about my project. It covers it shows a sample of how my web application looks. It covers about the data set, how we are going to upload the data set, how we are going to see the results, how it's going to show that if the data is anomalous, or is it the poison data, or it's in the good range of data. So we can go through each and every slide for the analysis. So So this is the web application. So the web application, the front end, I built it on React, and the back end is totally fast API. And for the testing and models, I used Python scikit-learn library, reward library, and for prediction and all the modeling things. And for the data set for this sample, I did a predict stress levels. I used the data set, and then I also did a data set on BMW sales day, BMW sales predicting data set. So I use two particular samples for my model in this example, and this is the snapshot of how it looks. So this is the snapshot of my web application. Here you can choose file and upload the data, and then after uploading the data, you can train the data. You can see uh, this is particular place where you want to see which category you want to predict. So in this case, I'm using the BMW sales data, and I want to predict sales classification. So basically, if you input the price as well as sales and volume of sales and which year the car is in, it predicts that if the car is high priced or low priced, depending about the data we have inputted. So that's about the model. And after you have inputted model, and after you have done this information and you click the train button, then it trains the model. So this is so what you have to do is that when you upload the data, you have to make sure this data is very accurate, because this is the default data. So after you have done training, then you can input the predict model manual. So as you can see that I've intentionally used uh, not so like data poison data into it. So it's 0.1, 0.2 for year. For the year column, it's 0 0.1, which doesn't make sense, because it has to be like 2001 or 2002, which is the year. But I've intentionally inputted 0 0.1 and engine size, and I've intentionally done all of these wrong values into it. So as you can see, the anomaly score is 0.6659, which says that the input data is actually not correct. So it's saying the whatever the input values you have inputted, it's not perfect. So that's how it we can see the prediction, and that's how it works. So let's go to the next slide. And then I'm explaining about the results which have been outputted. So we can see we can see that there's y hat, which is the prediction. It says that it gives out 0 and 1, which says that yes or no data. It's like a binary classification. So if we are predicting that whether the BMW sales are high or no low, so it's high, let's say high is 1 and low is 0, so it gives out the output value, output predictive value according to the inputs given. And this I have already explained, since the data inputted is a little different, and which is not supposed to be that way, the score is pretty high. And it has to actually say that drift alert is true, but it has to be calibrated a little more. So the threat score is pretty high, which says that the data is poisoned. So there needs to be a little more sampling done, and they're saying it the sampling is underdefined because there is not enough values. Once we have like lots and lots of values, then it would say defined. And yep, that's about the uh, results. And we can see that so most of this works on logistic regression. So we have discussed already two samples which have done, that is stress level and BMW sales data set. And then it uses Advent drift anomalous algorithm. So using this Python algorithm, using this library, I could find out that the data is actually not perfect, using this and isolation and along with the isolation forest, using these both, I could find out these. And as you can see, I have already said that it needs a little more calibration too. So that's how we can find if the data is poisoned or if the data is actually good. So the analysis of the finding. So the main aim is to create a secure machine learning workflow so that we can see for the future data if the data is accurate. That's the main aim. And some of the strengths are it has very high accuracy in classification models. So if you want to see a model which is if you want to predict a model which has yes or no questions according to the inputted numerical data, then it works pretty good, and it has very high accuracy for those models. It is a reliable model and drift detection systems. So it is a pretty reliable model too. And yeah, it is usable, and it, as you can see, it is user friendly, and the instructions are pretty good on the web application too. You just have to upload the data set and then predict, train the data, and then you can input data and see that if the data is actually good or if it's poison data. So it's a easy model. I also have few limitations for my web application, which is the numerical feature restriction. uh, if you want to predict numerical data, this is predicting only the uh, only model which has yes or no questions like classification data. But if you want to do numerical prediction, that feature is right now not available because of time is not permitted. It is it's right now not done because I'm using logistic regression models. So it is only yes or no questions, I mean, most of the time. So only the classification is working, but numerical prediction, it's still not there. So that is one of the limitations. And so the data has to be pre-cleaned before we input into this model. I wanted to do it through our algorithm, but again, the time limitations, I couldn't do it. But the data needs to be, if we have any data which is not properly clean, if it has a few unavailable values or the other values, then it's going to be a problem. So the data which has to be inputted is should be pre-clean data. So that's another thing. And as I have mentioned earlier too, the threat score needs a little bit calibration, because 0.66, it's actually the data which has to be say that it is poison data, but it's not saying because it needs to be calibrated to 0.66. And I've tested with the other models wherein I inputted the right data, and the anomaly score would come down to zero point 0.2. So I could make it such a way that if it crosses zero point 0.5 threshold, it says that the data is most likely poison. So that's the other limitation. Yep. Uh, so according to the limitations, these are again the same thing, repeating that there's only specific use case application for the logistic regression models which it works. So that's the trade-off user has to make. Yeah. And then validation and reliability. Uh, so the unit has to be uploaded, and the schema is built. After the data set is uploaded, then the schema goes into the data set goes into the model, and then it classifies all the data. It classifies numerical data and non-numerical data, and then it does accuracy testing, and then it does the integration testing at the back end and front end consistency. And it does also the uh, reproducibility across multiple screens and across multiple software. So since it's web application, it is pretty scalable, and it works across most of the web apps or web browsers. It works on it. and it is also pretty stable since I've tested it. Yeah. And this is about the case study. In this particular case, BMW sales data set which I've done, and the I could see that the model is pretty accurate, and extreme values are flagged because I can see that I've entered wrong data intentionally, and I could see that the drift score was going 0.666, which is pretty high. It should have been zero point 0.2 in that range. If it's in zero point 0.2, then I can say that the data is pretty good. But if it goes about 0.666, it means that the data is most likely been poisoned. And there's problem in the data we could see, and we can also predict the data. Like I said, it's a classifier, so when you inputted the data, it would say that for this particular example, if the price is very high or if the price is very low, for this BMW sales data set. And summary and transition. The summary is that the front end we used upload data and then predict the data, and then train the data, and then we predict the data. So that's the front end. And back end, as you know, we have used the logical regression models and admin algorithm, and to find out if the data is uh, anomalous or if it isn't. And yep. Yeah, and the limitations, like I mentioned, it works pretty good with logistical regression models, but doesn't work with the numerical models if you want to predict the numerical models. And it also doesn't perform well with the unclean data. So these are the slight uh, limitations which I would like to uh, improve uh, for the future models. And that's the end of my presentation. Thank you for bearing with me. Thank you.